All right, y'all, we've got the beloved quadratic formula today. So we've got 5.8a, which is solving quadratic equations by the quadratic formula. And our objective is to solve quadratic equations using the quadratic formula. Okay, so we've learned how to solve by factoring, solve by square roots, solve by completing the square. And there are times that you're going to come about something and you're not going to be able to solve by factoring. You're not necessarily going to be able to solve by square roots. And you're like, what do I do? This is what, I mean, like this, using the quadratic formula, that will work every time to solve a quadratic equation. Sometimes it's just very lengthy, and so we don't always want to use it. However, it's always there for us to be able to use. So I highly recommend knowing how to use it. So that's why I'm teaching it to you. And so first of all, we have to remember that our quadratic equation is ax squared plus bx plus c equals 0. Okay, so the quadratic formula, we need to know the a, b, and c because the quadratic formula is negative b, or opposite. You really should say the opposite of b. Everybody's like always says negative b. I know I do too. It's just out of habit. But really it's the opposite of b, so the opposite sign that b has. Plus or minus the square root of b squared minus 4ac all over 2a. This is something that you have to memorize. It will not be given to you. You have to know what you're doing because especially on the ACT, you're going to have to solve a quadratic equation, and guess what? It most likely cannot be factored. So you're going to need to know the quadratic formula, and it's not going to be given to you. So, and please note, like the plus or minus comes from because when you take the square root of a number, you have the positive number and the negative number. So that's the reason why you have plus or minus. Now we will separate those in our answer. Okay, so let's take a peek at our first problem where we're going to solve with the quadratic formula. So I have 2x squared plus 6x plus 1 equals 0. Just like solving by factoring, you do need it set equal to 0 in order to solve. Okay, so now what we've got is we need to identify our a, b, and c. So a is 2, b is 6, c is 1. So now I'm going to substitute into the quadratic formula. So the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So you're going to substitute everything in. Now I will go ahead and take this one piece at a time. So the opposite of b is negative 6. Plus or minus 6 squared is 36. And so what I personally do in my calculator is I will type this in, excuse me, as negative 4 times 2 times 1. Okay, so when I do that, when I do negative 4 times 2 times 1, I get negative 8. So that means it's going to be 36 minus 8. So that's the big thing to realize because once you start getting negative numbers within there, it becomes a little bit more complicated. So I personally just treat it as negative 4 times 8 times c, figure out what that number is, and then that's the sign that it's given. All over 2 times 2 is 4. So now my next piece, I'm gonna basically do the 36 minus 8. So I have negative 6 plus or minus the square root of, and that's going to be 28 all over 4. Now I'm going to try to simplify that 28 so I can do 4 and 7, and the 4 I can break up into 2 and 2. So I am going to take out a 2. So I have negative 6 plus or minus 2 square root of 7 all over 4. Now, the one thing that I look at it, that might be the easiest way to look at it is look at your numerator, okay? Looking at your numerator, see if there's something in common that you can factor out. With 6 and 2, I can factor out a 2. So I'm going to factor out a 2, and I'm left with negative 3 plus or minus 1, which I don't actually have to write, square root of 7 all over 4. Now I'm going to look at what I factored out in the denominator, and I'm going to see, oh, can I reduce that? I can. So I'm going to go ahead and divide by 2. Now, if it's a case like if I had 2 and 7 or something like that, okay? If you cannot reduce, then this is going to be your answer, okay? What I'm circling right here. That's going to be your answer. But if you can reduce, then you need to. And I always look at factor out the GCF in the numerator, see if you can reduce the numerator, like what you factored out, and the denominator, okay? Again, if you cannot, you go back to before you factored out, because this, like, if a factored out numerator will actually not be your correct answer, okay? But I can reduce it by 2. So what I end up getting 1 here. So I don't really have to write that 1. And so I have negative 3 plus or minus the square root of 7 all over 4 divided by 2 is 2. Now for your final answer, you do want to separate the plus minus. The reason why I state this is, like, does it truly matter if you gave me this as your answer? No, not really. I'm going to be honest with you. However, one thing that I will say is at the collegiate level, if you're taking any kind of class like the LSU class that I teach, if you type it in like this, it will not give you that answer correct all the time. You do need to separate the two. So I will state that x equals the negative 3 plus square root of 7 all over 2 and negative 3 minus square root of 7 all over 2. The other big reason why you do want to separate it is, what if your a is negative, and so you end up getting a negative in your denominator? It's not really fully simplified. Usually you want your denominator to be positive. So, so that's just kind of one thing to keep in mind. I do have I have 3 other examples that I want to look at. So I'm just going to save that for the next video because we're getting close to that 10-minute mark, and I think I can just kind of whip right through the rest and be able to make it in the 10 minutes, okay? So we will take a peek at the next video.